Okay, just when we were beginning to have fun, we had a little technical difficulty, but we're back streaming now. So where we left off, we had x plus 6 squared equal to x squared plus 12x plus 36. Now, if you were in a class with me, I would ask you the question, what pattern do you see as you go from left to right? What is the relationship between the numbers here and the numbers we have on the right side? I said, really now, is there a pattern? I have a 3 here, and what numbers do I end up with over there? We will forget the first term because they're always the same. Nothing dramatic with the first term. But I noticed that the middle term and the last term, those numbers change, those coefficients change. So I notice if there's a 2 here, I have a 4. If I have a 1 here, I have a 2. If I have a 3 here, I have a 6. If I have a 4 here, I have an 8. Is there a pattern? I think so. If I have a 5, I have a 10. 6, I have a 12. So do you think if I had a 9 here, that I would have an 18? Yes? Isn't that what it looks like? So it seems to me that the middle term is always double this number. Whatever this number is, it's doubled right here. Keep that in mind. Now, what about the last term? Well, we have 2, we have 4. 1, we have 1. 3, we have 9. 4, we have 16. What's the relationship between this number and the last number? It seems to me that the last number is obtained by squaring the last number, the second number in the constant in the binomial. So 2 squared, 4. 1 times 1, 1. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. So by squaring the number here, we get the constant. And by doubling the number here, we get the middle coefficient. That's very important because completing the square requires us to go from the right to the left. It requires us to take an expanded version of a trinomial and create a perfect square. So let's go ahead and try that now. And once we get that thought process in, we'll start using that to solve a quadratic equation. So the instruction is complete the square. One. If I gave you x squared plus 14x what should I put here so that this is a perfect square? Well, the middle number we know comes by what we're trying to do. We're trying to get something like this squared. We're trying to get something like this squared. So this middle number is always obtained by doubling whatever number is here. So it seems to me that the number should be 7. That's the number here that would give us a middle term, that's 14. And what is the number that we need to complete the square? It's 7 times 7, 49. So now we have a perfect square. X squared plus 14x plus 49. Let's try another one. X squared plus 10x. What do I need to put there to make a perfect square? The answer is, if x squared is here, what number would have to be in the box or in the parentheses? to make that 10, the answer is a half of 10, which is 5. And of course, the perfect square would be 25. So we need 25 to complete the square. Now, somebody's going to ask me, what happens if there's a negative sign? Oh, okay. If there's a negative sign, then all that's going to happen is that you end up with a negative sign in the binomial. So, suppose we had y squared minus 6y plus. This number will always be plus if it's a perfect square. Then the answer is y minus, the number that goes here is a half of this number. So it has to be minus 3. And then minus 3 times minus 3 gives us positive 9. So that's a perfect square. So what we're going to do now is we're going to solve an equation, a quadratic equation, using the method called completing the square. Now, in order for you to be able to appreciate the method and know that it works, we're going to use an equation that we already know the answer, and then see if when we do completing the square, we get those answers. So let's go. Solve. X plus, so x plus 4 times x minus 2. If you're asked to solve that from the method called zero product property, something times something equal to 0, we know that the answers are x equal to negative 4 or x equal to, from here, positive 2. This, again, the zero product property is from a previous lesson. So these are the two answers we expect to receive when we're finished doing this using the using completing the square. So let me put the equation right here. And we're going to check it out and say, okay, what is that when we expand it? It's going to be x squared, x times x is x squared, x times negative 2, negative 2x. 4 times x, 4x. 4 times negative 2, negative 8. So now we have x squared plus 2x minus 8 equal to 0. So now we want to solve this equation using completing the square. How do we do that? Okay, so the first thing we do is we move the negative 8 over to the other side. So now we have x squared plus 2x equal to positive 8. How do we get rid of this negative 8? We add 8 to both sides. So now we're ready to complete. This step is a step called, from here to here, is the step called completing the square. In order to have a 2 in the middle, it means that we must have x plus 1 squared. Because x plus 1 times x plus 1 is going to give us x squared plus 2x plus 1 times 1 is 1. But there's no 1 here, so therefore we have to minus 1 so that this line is equal to what is here. The right side stays the same. We do not touch the right side. What we did, we moved the 8 over here, and your focus is just these two. X plus 1 squared minus 1 is going to be the same as x squared plus 2x. It's going to be exactly like that, because from here, we're going to get x squared plus 2x plus 1. So to get rid of this 1, we have a minus 1. So you end up with just x squared plus 2x, which is what was here. And now we're ready to solve this equation. Add 1 to both sides, we end up with x plus 1 squared equal to 9. We need to get rid of the square by finding square root of both sides. When we find the square root of 9, we're going to get plus 3 or minus 3. So we end up with x plus 1 equal to plus or minus 3. That's the square root of 9. So we're going to get one answer by subtracting 1 from positive 3, and the other answer by subtracting 1 from negative 3. So what do we end up with? X equal to plus or minus 3 minus 1. So x is equal to 3 minus 1, or x is equal to negative 3 minus 1. Therefore, x is equal to 3 minus 1 is 2. And negative 3 minus 1 equal to negative 4. And those were the two answers we had before. So what I'm trying to show you is that the method completing the square does give you the same answers. That's what I wanted to show. So going forward, I will not do this. I will just go straight into a question like this to solve. And let's see what happens. So let's go to a second question. So solve x squared plus 12x minus 4. How do we solve this? Well, the method that we discussed was we remove the negative 4 over to the other side. We end up with x squared plus 12x equal to 4. And now we're ready to complete the square, and your focus is only on the left side, just the left side. So we know we end up with x positive 12. You half this, you divide this by 2, you get positive 6 squared. But when you square this, you're going to get x squared plus 12x plus 36. There is no 36 here. So to make this statement equal to these two terms, you have to cancel that. You have to subtract 36. And of course, on the right side, you do have your 4. And now, put this over here. We add 36 to both sides. We end up with x plus 6 squared equals to 40. 36 plus 4 is 40. And now we're ready to find the square root of both sides. We end up with x plus 6 equal to plus or minus the square root of 40. In another class, I will show you how to reduce this radical. So right away, you see that this is a question that could not be solved by factoring because you did not get a perfect square. 40 is not a perfect square. You will end up with a decimal, okay? But later on, you will know that that reduced square root of 40 is actually equals to 2 root 10. But I have not taught you that yet. This is for another class. But for now, we just leave it as plus or minus the square root of 40. Okay? And now, we get rid of the 6 by subtracting 6 from both sides. We end up with x equal to negative 6 plus or minus the square root of 40. And for now, this answer is what you would leave it as. If you did the quadratic formula, you would end up with something very similar to this. Actually, it will be equal to this, but it might be simplified a little bit more. We will discuss radicals in another class. Okay, so this is how you would solve this equation using completing the square. Let's try another one. So, x squared minus 14x plus 49. Okay, equal to 0. Okay, ready? Here we go. Get rid of this over to that side. So we end up with x squared minus 14x equal to negative 49. And then we end up with x minus 7 squared minus 49 equal to negative 49. How did we get this right here? By dividing this by 2, we get negative 7. How do we get this? I call this the adjustment. How do I get this adjustment? Just by squaring 7. 7 times 7 is 49, but you have to subtract this because if you add x minus 7 times x minus 7, you will get x times x, x squared, x times negative 7, negative 7x. Negative 7 times x, negative 7x. Negative 7 times negative 7, positive 49. Equal to x squared minus 14x plus 49. When you expand this, you get a trinomial 1, 2, 3. But what you had above it was a binomial. There is no third term. So in order to make this part equal to this part, the left side here equal to the left side, you have to minus the 49 to cancel this. When you minus the 49, this becomes 0. And now you have the x squared minus 14x, which is what is above. That is the reason why you have to do that adjustment. Okay? So this one, add 49 to both sides, we end up with x minus 7 squared equal to 0. Oh, okay? So, what do we do here? When we find the square root of both sides, we end up with x minus 7 equal to plus or minus 0. Remember, we need to get two answers. It is a quadratic equation. We need to get two answers. And in this case, we end up with x equal to, add 7 to both sides, we end up with 7 plus or minus 0. So we end up with two answers, x equal to 7 or x equal to 7. In other words, you end up with two identical answers. Because look at this. It is x minus 7 squared equal to 0. What does the square mean? X minus 7 times x minus 7. Each binomial gives you one answer. So this gives you 7, that gives you 7. So that's why we end up with 7 twice. And remember, a few lessons ago, we talked about multiplicity. It's when one solution is repeated in the same question. So you could say that x is equal to 7 with multiplicity of 2 because it's repeated twice. Got it? Yes. Okay. So far all the questions we have done have an even number in the middle. So you must be saying, what happens if this number is not an even number? How do we proceed? I'm so glad you asked. Let's go and see what happens with a case like that. The math does not change if the number change. The math is consistent. So we have to get the method down clear. And once we have the method, stick with the method and the math will work itself out. Okay, let's do something that looks really ugly. Say, for example, y squared plus 5y, whoa, minus 8 equal to 2. That's different. That is different. So, what is the math that they have discussed? What is the procedure? What are the steps? I'm glad you asked. The first thing we did was we removed the constant to the right side. So we add 8 to both sides. We end up with y squared plus 5y equal to 10. Nothing dramatic. We remove the 8 over there. It becomes positive 8. 2 plus 8 is 10. Now watch the magic. This is a magic now. How did we get our parentheses before? The method doesn't change. How do we get our parentheses? Well, we always put this by itself here. Since this is a plus, we will put a plus here. The method says you divide this by 2 and place it right here. So 5 divided by 2 is a fraction. So that's what you do. You put your square here, and the right side remains 10. But remember, we have to make our adjustment. What is the adjustment? The adjustment is always this number squared. So it's 5 over 2 times 5 over 2. And what is that? 5 times 5? 25. 2 times 2? 4. So your adjustment is 25 over 4. It's the same thing we did before. When there was a 7 here, we put 49. When there was a 10 here, we put 25. If there was a 12 here, we'd put 144. It's always this number squared, and it is always minus, because this is a binomial. This is going to give you 3 terms. So that's why you have to subtract the third, so that this is equal to this. Okay, don't let the fractions scare you. Treat them just like you treat the other numbers. Okay, what did we do next? We brought this over here. So now we have y plus 5 over 2 squared is equal to 10 plus 25 over 4. How did we add fractions before? We said in order to add fractions, we need to get a common denominator. So this is 10 over 1. Common denominator of 1 and 4 is 4. So therefore, we can write y plus 5 over 2 squared is equal to 40 plus 25 all over 4. And that is 65 over 4. Okay? So here we can take it over to this side to finish. So y plus 5 over 2 squared is equal to 65 over 4. So let's bring it up here. Let's get rid of the square. So now we end up with y plus 5 over 2 equal to plus or minus the square root of 65 over 4. All I'm finding is the square root of the left and the square root of the right. That's 65 over 4. We know that the square root of 65 is ugly. But the square root of 4 is a good number. So it is plus or minus the square root of 65 over, what's the square root of 4? 2. And when you get into this level of math, you don't need to write a decimal for this radical. You could leave it as a simplified radical. This one cannot be simplified. It cannot be reduced. So in this level of math, it's okay to leave your answer as the square root of 65. A previous question, we had the square root of 40. That can be reduced, but I'll explain that in another session. Okay? Get rid of this over here. So we end up, it's going to become minus 5 over 2. It's a positive, so we have to subtract. So y is equal to, it's always good to write the radical last. So you write you write the whole numbers first and the radicals last. Okay, so now we have negative 5 over 2 plus or minus square root of 65 over 2. See the common denominator? So you could write y equal to negative 5 plus or minus 65 all over 2. So the negative 5 plus or minus 65 and the denominator is 2. This would be your answer. And if you did the quadratic formula, you would get this answer. It will be exactly what you have here. So good news, completing the square can be used to solve any quadratic equation. Quadratic formula can be used to solve any quadratic equation. Factoring can only be used to solve those quadratic equations that can be factorized. And graphing can only be used to solve quadratic equations that cut the x-axis. If it has imaginary solutions, it will not work. Whereas completing the square and the quadratic formula can be used to solve all quadratic equations. So it's good to know these tools. Okay, let's try another one. I'm sure as you're looking at what we're doing now, you remember the days when we just started, oh, the math looked so simple. And you're saying, where are we going? Now the math is looking a little bit more involved. But I hope that I'm explaining it enough for you to understand. So let's do another example. So let's change up the letters just for the sake of it. So we have a squared plus 3a plus 2. Okay, equal to 0. The method doesn't change, even though the numbers might be different. So here goes, let's move the 2 over to that side. So we have a squared plus 3a, let's write it here. A squared plus 3a equal to negative 2. Now we're ready to complete the square. So we have our parentheses, and we put our square. Inside we have our a. This is a plus, so we put our plus. And it's always this number divided by 2. So it is 3 over 2. The right side stays here, but because of this, you have to make an adjustment. And the adjustment is this squared. So it's 3 over 2 times 3 over 2. And that gives us 3 times 3, 9 over 4. So we minus 9 over 4. So now our goal is to get a by itself. So you have to get rid of this, get rid of that, and then get rid of this. step by step by step. So how do you get rid of this? You add 9/4 to both sides. So a plus 3/2 squared is equal to -2. Ooh, this is ugly. It's equal to -2 plus 9/4. Okay, so how do you simplify that? Well, I'm glad you asked. -2/1 plus 9/4. Get common denominator, it is 4. If this becomes 4, then this has to become -8 plus 9. So -2/1, if you multiply the bottom by 4, 4 times 1, 4, 4 times -2, -8. -8 plus 9 is 1/4. So we have a plus 3/2 squared is equal to 1/4. And now we're ready to find the square root of both sides. So we end up with a plus 3/2 equal to plus or minus the square root of 1/4. I'm going to take this and finish it right here. Now we have a plus 3/2 equal to plus or minus. What is the square root of 1? The answer is 1. What is the square root of 4? The answer is 2. So the square root of 1/4 is 1/2, because look, 1/2 times 1/2 is 1/4. So 1/2 squared is 1/4. Square root of 1/4 is 1/2. Okay? How do I get rid of the 3/2? We subtract 3/2 from both sides. So a equal to -3/2 plus or minus 1/2. So one answer is a equal to -3/2 plus 1/2. Or the other answer is a equal to -3/2 minus 1/2. What does this become? A is equal to, denominator is 2, -3 plus 1 is -2. So a is equal to -1 from this. Or a is equal to, common denominator is 2, it's -3 minus 1. What is -3 minus 1? -4. 2 into -4 is -2. So the answers are -1 or -2. Those two answers would work perfectly. Did you notice that these two, this trinomial could be factorized? Did you notice that? I noticed it afterwards. So let's see if we'll get the same answer. The same answers. So if we go, we get a squared, you know it's a and a. What two numbers multiply to give you 2 and add to give you 3? Well, 1 times 2 is 2. 1 plus 2 is 3. So it's going to be +1 plus 2. I guarantee you that these two binomials multiply and simplify to give you that. And from this, using the zero product property, you put this equal to 0, you put that equal to 0, and therefore you end up with a equal to -1, or from here, a equal to -2. We used the zero product property in a previous session. So that's why I'm applying it now, because I've taught that as a principle before. And those two answers are exactly the answers we got with completing the square. So now it's time to do a more complex question on completing the square. A much more complex question. So stay tuned. Let's go. Did you notice that all the questions we have done so far, our lead coefficient was 1. It always started with the first term, the quadratic term, having a coefficient of 1. Let's increase and change that from 1 to something else. So if I had 2x squared plus 18x minus minus 5. Yeah, why not? How do we do this? Well, I said to you earlier that any quadratic equation can be solved using completing the square. So let's go ahead and try. Let's stay with the method that we have been using. We get rid of the negative 5 by adding 5 to both sides. So now we have 2x squared plus 18x equal to 5. All the examples we have done before had x squared as 1 in front of it, as a coefficient of 1. So let's divide both sides by 2. We now have x squared plus 9x equal to 5 over 2. So guess what? Now we're back to where we were the last time. You have something exactly like what we have done before, and now we're back in business. So ready to complete the square, we go zoom, zoom. It's going to be x and plus 9. A half of this is plus 9 over 2. See, it is 9 divided by 2. We don't like decimals. We don't like to use decimals. This looks pretty. The decimals are ugly. Okay, now we have to make the adjustment, and the adjustment is always this squared. So it's 9 over 2 times 9 over 2 gives you 81 over 4. Let's double check. 9 over 2 times 9 over 2. 9 times 9, 81. 2 times 2, that's how you multiply fractions. You multiply the numerator, you multiply the denominator. And that's how you get 81 over 4. And we continue. We need to get x by itself. So we have to get rid of this negative 81 over 4. We have to get rid of this square. And we have to get rid of this 9 over 2. So we go 1, 2, 3. 3 steps to get to where we're going. So add this to both sides. We end up with x plus 9 over 2 squared is going to be equal to 81 over 4 plus 5 over 2. And of course, the common denominator is going to be 4. 5 over 2 is the same as 10 over 4. 5 over 2, if this is going to be 4, this is going to have to be 10. 2 times 2 is 4. 2 times 5 is 10. So 81 plus 10 is 91 over 4. So x plus 9 over 2 squared is equal to 91 over 4. All we did was add these two fractions and by getting the common denominator. So now we're ready to get rid of the square by finding the square root of both sides. So we end up with, well, I'll write what we have. We have x plus 9 over 2 squared equal to 91 over 4. Find the square root of both sides. We end up with x plus 9 over 2 equal to plus or minus the square root of 91 over 4. Square root of 91, you can't, there's no square root. As a matter of fact, it can't be reduced, it can't be simplified. 91 is 7 into 91 goes 1, 13 times. So it's 7 times 13 give you 91. So there's no perfect square. So now we end up with x plus 9 over 2 equal to plus or minus the square root of 91 over square root of 4 is 2. All we have to do is to bring this over to that side. It becomes negative 9 over 2 plus or minus square root of 91 over 2. So then we can put it all together. It's negative 9 over 2 plus or minus the square root of 91 over 2. They both have the same denominator, so you could write it as one fraction and have x equal to negative 9 plus or minus the square root of 91 all over 2. And that will be your final answer. So here it is. We started off very simple and developed, and now we have a more sophisticated, I didn't say difficult, just a more sophisticated looking math problem. Okay? So this is what I'm going to do. I'm going to do another example, and then I'm going to do the same example using the quadratic formula so that we can see that the two are consistent. And then that should give you really a good feeling about completing the square. Okay, so what I'll do this time, I'll solve using the quadratic formula first, and then do the same question using the completing the square, and hopefully we'll get the same answers. Here we go, solve 3y squared. Can I make it really, really, really ugly? Yes. Let's put stuff that is not easy to work with and see if we can fight our way through. Okay, so 3y squared minus 4y. This is going to be really ugly. This is really ugly, okay? Let's go. So A is equal to 3, B is equal to negative 4, C is equal to negative 8. The quadratic formula says y is equal to minus b plus or minus the square root of b squared minus 4ac all over 2 times a. That is a quadratic formula. We covered this maybe about 2 sessions before, 2 or 3 sessions ago, whatever. So this was done already. So we're going to use it now that we have already covered it. So in this case, b is negative 4. So negative b is going to be positive 4 plus or minus the square root of, what is b squared? Negative 4 times negative 4 is 16. Minus 4 times a. What is a? A is 3. And what is c? C is negative 8. And it's all of that over 2 times a. 2 times 3. Let's keep going. So we have positive 4 plus or minus the square root of 16. And what do we have? Negative 4 times 3 is negative 12. Negative 12 times negative 8 is positive 96. All over 6. And we simplify, We end up with 4 plus or minus the square root of 16 and 96 is 6 and 6, 12 is 112 over 6. Since I did not discuss with you how to reduce the radical as yet, we'll just leave our answer like that. Reducing the square root of 112 is a process, and we're not going to do that today. It's not. We haven't covered that yet. We'll cover that another time. So I'm going to put the answers right here. So we're looking for 4 plus or minus the square root of 112 over 6. We're looking to get those same answers doing completing the square. So this is where you keep your fingers crossed, because if I don't get these answers, then something is wrong. Uh-oh, fingers crossed. Here we go. Step 1, let's move this over to the other side. So we end up with 3y squared minus 4y equal to 8. Step 2, get rid of this 3 so that we just have y squared. Divide everything by 3. So we have y squared minus 4 over 3y equal to 8 over 3. What have I done? I've divided the entire equation by 3. I divided the left-hand side by 3. I divided the right-hand side by 3. Not a problem. It is acceptable in math world as long as you do the same thing to both sides. The equation is still balanced. So now I'm ready to complete the square. It's ugly, but we can do this. So what is the process? It says it's going to be y, there's a minus sign, and we need to divide this by 2. We need to divide this by 2. Well, watch this. Sidebar. 16 divided by 2 is 8. 16 multiplied by a half is 8. 21 divided by 3 is 7. 21 times 1 over 3, 1/3 is 7. What am I trying to tell you? To divide by 2 is the same as multiplying by a half. To divide by 3 is the same as multiplying by 1/3. To divide by 5 is the same as multiplying by 1/5. To divide by 4 is the same as multiplying by a quarter. So dividing is the same as multiplying by the reciprocal. This is the reciprocal of 2. This is the reciprocal of 3. Okay, keep that in mind. So truthfully, if somebody said to you, divide 24 divided by 2/3, it is the same as 24 multiplied by, just flip it, 3 over 2. It's the same thing. You flip it, that's a reciprocal. The reciprocal of 2/3 is 3 over 2. Reciprocal, it's flipped. What's on the bottom goes to the top, what's on the top goes to the bottom. So to divide this by 2 is 4 over 3 multiplied by a half. So it is 4 over 6. And 4 over 6 is the same as what? 2/3. Okay? So we put 2/3. And of course we put our square because we're completing the square and we have to do the adjustment. What is the adjustment? The adjustment is this squared. Whatever number is here, multiplied by itself. 2 over 3 times 2 over 3 is what? 2 over 3 times 2 over 3 equal to 2 times 2, 4, 3 times 3, 9. So we minus 4 over 9. And that's equal to what's on the right side. Now, what do we do as we did before? Nothing changed. The math doesn't change. All that changed is the numbers. Now we have some numbers that are ugly, but we're not afraid. The math remains the same. So let's add 4 over 9 to both sides. So y minus 2 over 3 squared is equal to 8 over 3 plus 4 over 9. Now, we know that to add these two fractions, we have to get the same denominator, which of course is 9. So 3 times 8 is 24. 24 plus 4 is 28 over 9. So now I'm going to take this over here to finish the job. So we have y minus 2/3 squared equal to 28 over 9. So now I need to find the square root of both sides. Square root of both sides so I can get to the y. I want to get rid of the parentheses. So therefore y minus 2/3 equal to plus or minus the square root of 28 over 9. So we end up with y minus 2/3 equal to, the top becomes plus or minus 28, and the bottom becomes 3. Okay? Now when we add this to the other side, we end up with y equal to 2 over 3 plus or minus 28 over 3. Sorry, the square root. Okay, so now what do we have? We have y equal to, common denominator is 3. And this is going to be 2 plus square root of, plus or minus the square root of 28. So then you're going to say to me, wait a minute. This is not the same as this. And I'm going to say to you, yes, it is. And you're going to ask me, prove it that this is equal to this. I want to suggest to you that this is the reduced form of this. Because we did not do radicals, that's why we did not simplify this. But now I am forced to show you how to simplify this so that you can see that it's the same as this. Okay? So watch. What am I going to do? I'm going to take this and show you that it reduces to this. So we have 4 plus or minus the square root of 112 over 6. Well, let's look at the 112. 112 is actually 4 times 28. Let's see. 4 times 8, 32. 4 times 2, 8 plus 3, 11. So the square root of 112 is the square root of 4 times 28. Okay. So what's the square root of 4? It's 2 times the square root of 28. Now, this can be reduced further, but because we're trying to get it to look like this, I'm not even going to waste time to go further. So I'm saying to you that the square root of 112 is the same as 2 times the square root of 28. How did I get that? Well, 112 is 4 times 28. The square root of 4 times 28 is the square root of 4 times the square root of 28. Square root of 4 is 2. Square root of 28 is right here. I could reduce this to 2 root 7 but this wasn't reduced, so I'm not going to waste time to do that. So what do we have now? This is equal to 4 plus or minus 2 root 28 over 6. And if I divide the top and the bottom by 2, divide the bottom by 2, divide the top by 2, what do we get? 6 divided by 2 is 3. 4 divided by 2 is 2. 2 root 28 divided by 2, they cancel. So we end up with just the root of 28. So you see that this is the same as this, which is the same as that. There it is. Okay, so what we have shown you today, today's session, is to show you how to use the method called completing the square to solve quadratic equations. It's pretty a neat technique. You know, you don't have to do as much memorization as to memorize the quadratic formula, but you have more steps, whereas the quadratic formula is more concise. Again, there are some questions that might, some professors or teachers who might say, I want you to solve this equation using completing the square. Or, I want you to solve this equation using the quadratic formula. So as a good math student, you want to have all the tools in the toolbox. You want to know how to factorize. You must know how to use the quadratic formula. And it's good to also know how to do completing the square. So if you go into college and the professors are talking about completing the square, you know exactly what they're talking about. Well, on behalf of the Rassis Brosis Foundation, I thank you for joining us for another session of learning together in math. I do hope that you found this interesting, and stay tuned for our next session. Have a great rest of the day.